In this video, we're going to look at a question on motion. Pause the video and try all parts of the question. 1a, an object is moving in a straight line at a constant speed. If it's moving at a constant speed, we know that the forces are balanced. That's important because it then says if forces applied to the object, state the possible changes in the motion of the object. So the question could be slightly clearer, but we're going to assume that this means an unbalanced force. So if the forces are balanced, it moves at a constant speed. If the forces are unbalanced, what could happen? Well, it could change speed. It could either increase its speed or it could decrease, depending on whether the force is acting in the same direction as motion or the opposite, or something that people often forget as well, although it's really obvious, it could also change direction. So if the object is traveling this way and we put the force at a different angle to the direction of motion, it might change direction. Part B. So it gives you some information about the skier and what the race involves, and then it calculates the skier's acceleration. So there's two formulas for acceleration. F equals ma, and a equals change in speed over time. And people often ask, how do I know which one to use? So we need to see what information we've been given in the question. So we've been given time, and we've been given a final speed. We've also been told they start from rest. So we've been told that the initial speed is 0, the final speed is 60, the time is 16 seconds. So obviously we're going to use this equation here that has these bits of information in. This is not useful because we don't have the mass and don't have the force. So the acceleration, change in speed over time, always sensible to write out the full working, and then we get our answer of 3.8 meters per second squared, or you could say meters per second per second. Right, there's no unit here, so if there's not a unit, always makes sense to write the unit in because there might be a mark for it. And I would always put the -0 in as well, just to show that you know it's change in speed, even though the initial speed was 0. Part II, so it says over the length of 100 meters, the time recorded is 1.85 seconds. Calculate the skier's average speed. So average speed is total distance over total time. So once you know that, it's really easy. 100 over 1.85, and that gives us 54, or you might have written 54.1 meters per second. And then finally, why does the skier bend his body as shown in figure 1.1? Explain your answer. Well, what is the point of this competition? It's a speed competition. You need the highest average speed. So the skier bends his body to be streamlined. So this is a key word, always worth putting in, which means to reduce the force of air resistance, slowing him down. And what is the point of that? So he can go faster. Okay, and just to make it really clear, this object here, not streamlined. This object here is streamlined. This one will move far more easily through the air. This one won't. This one will have a higher terminal velocity, which is ultimately what might happen at the end of this if the skier reaches a constant speed than this. This will have a lower terminal velocity.